We'll begin this one with parent functions. The other trig functions, tangent and cotangent, secant, cosecant. The tricks to graphing both of them, or both sets of them, is all the same. If you can graph sine or cosine, you sure as hell can graph cosecant or secant. You already know how to. It's just one more step. Secant, cosecant requires one more step from sine and cosine. We're super basic. Something called connecting your humps, but it's neither here nor there. All right, let's get into it. Now I'm just going to give it to you right off the bat. Here's tangent. All graphed up, saying that the period here, the period is pi, which means this gap right here, from negative pi over 2 to pi over 2. That's pi, right? Half of a pi plus another half of a pi gives you one whole pi, right? Next. We talk about the domain. What's the shit you're allowed to plug in? What x values can you plug into a function? And it's like, dude, don't plug in any pi over 2s. Don't plug in any x equals any pi over 2. So like 1 pi over 2 or 3 pi over 2. If we kept going, there'd be a 5 pi over 2. No negative pi's over 2. No negative 3 pi's over 2. None of this shit. No. Not allowed to have it. Now this notation at the end, it's kind of jacked up, huh? N pi, and that, what's n? They don't even define it. For n, they're defining to be an integer. You know what an integer is? Give you just a set of them. Just give you a couple of them, not all of them, like -7 and -1 and 0 and 4. Whole numbers, positive and negative and shit like that. Huh? Any multiple of pi, just saying like add some pi's to it. Yeah, you got half a pi and now I give you 19 more pi's. Don't you still have 19 in there? You still got the half a pi left over, right? That's what it's saying. You're just getting some whole pi's. But if you started off with a half a pi and you ain't ate it yet, you're still going to have a half a frickin' pi, huh? Yeah, whatever. You know, mixed numbers. Well, the range, what's the range? What's all that shit about? What's the range about? Isn't the range about, oh, that's the y values, right? So it's saying that this will travel, like, let's look at our first one. Oh, there it goes. The heights, that's the y's, you know? Okay. Vertical asymptotes. Hey, those vertical asymptotes, what we're talking about here, that's the same thing as the domain, all right? You may not pass. And the reason is, don't frickin' divide by 0. Don't divide by 0. You'll see in a second exactly why. Well, and then you got some x-intercepts, you got some y-intercepts, you got symmetry about the origin, and this is what we call an odd function. I don't really talk about sine and cosine. This is an odd function. You're going to need to know that. That's an odd function. By the way, y equals sine of x is also an odd function. I'll leave this up to you to look it up. What an odd function might mean. And y equals cosine of x is an even function. I don't stress it too much in the first section. It's in the second section that I'll really press this. But if you're interested and want to know more on it, go look that up. Just type it in YouTube. You'll find something. So I will be back to it. But you will need to know the tangent is an odd function. You're hearing this, right? Tangent is an odd function. Cool. Homework, Mike. I see that. All right. I better jam. I don't want to take up all your time. Let's show you why. Y equals tangent of x. There's no such thing as tangent. There's no such thing as tangent. There's sine over cosine. All right. Let's just choose some values for our table. Remember this little table thing I made? I think it was sine, cosine. Oh, but you know what's happening now? It's not thetas. It's your x values. And these are your y values. Right, y equals sine of x, y equals cosine of x. And we're just going to look at 0, pi over 4, and pi over 2. Okay? Just that. Sine of 0 is 0. Cosine of 0 is 1. Cosine of 0 is 1. All right, cool. Go to pi over 4. That's root 2 over 2, root 2 over 2. And then we go to sine of x is equal to sine of pi over 2 is equal to 1. Cosine of pi over 2 is equal to 0. And then we move over to tangent. All right, there's tangent of x. So we get 0 over 1 is 0. So that's telling us that tangent of 0 equals 0. Therefore, we have the point 0, 0. All right, 0, 0. And then we'll get root 2 over root 2. That's equal to 1. So tangent of pi over 4 is equal to 1. So when you plug in pi over 4, you get 1. Neat, neat, neat. And then tangent of pi over 2, this one's undefined. Because there's no such thing as tangent. There's only sine and cosine. So when cosine is in the denominator, all odd multiples of pi over 2 will create a vertical asymptote. By the end of this term, you better be getting it. Odd multiples of pi over 2 will make tangent undefined. It's where cosine equals 0 with those odd multiples of pi over 2. So we find out that we have vertical asymptotes there. Now, if we were to play the game, you'd find out since sine's an odd function, cosine's an even function, it just ends up looking like this. So right here at, say, pi over 4, that's where the height is equal to 1. That barely looks like a 4, and this would be negative pi over 4. Okay, there it is, and you get your negative 1 out of it. Let's go to cotangent. Cotangent. There we go. I'm not going to talk on this. I'm going straight to it. Y equals cotangent of x. There is no such thing as cotangent. It's cosine over sine. Cosine over sine. Remember this table from back here? Let's see if we can't figure out what cotangent is going to be. Cotangent of 0 is going to be equal to 1 over 0 because it's cosine over sine, so cotangent of 0 is equal to undefined. We go to cotangent of pi over 4. Well, shoot, that's just going to be root 2 over 2 over root 2. That's 1. And now we go to cotangent of pi over 2, and we're going to find out we have 0 over 1, and now that one's going to equal 0. If we were to keep going and say cotangent of 3 pi over 4, we're going to end up with, well, I'm just going to let you know, we end up with negative 1 because cosine's negative in the second quadrant and sine is positive in the second quadrant, and it still has a reference angle of pi over 4, hence you get negative 1. Also, tangent's negative in the second quadrant, therefore cotangent's negative in the second quadrant. And then if we were to go to cotangent of pi, we would end up with, it would be, wait a second, that would be cosine of pi over sine of pi. That would be negative 1 over 0, which would be undefined. And this is the reason why, when we go to cotangent, we will see that its graph, everywhere you have a multiple of pi, here, there's 0 pi's. Here's one of the pi's. Here's 2 pi. So 0's bad. So no pi's are bad, 1 pi's are bad, negative pi's are bad. It's like you're talking to a nutritionist or something saying there's no frickin' pi's, and you're like, but I want pi. Cotangent. It's because you can't divide by 0. Sine equals 0. Sine equals 0 and all multiples of pi. That's why the domain is like everything but multiples of frickin' pi. The range is still anything you frickin' want. The period's still just pi. Unlike sine and cosine, and cosecant and secant, the period is just pi for tangent and cotangent. It repeats quickly. This is also a decreasing function. You see there's actually, it's like going down the slide. It's a decreasing function, always. A little different than the others, but cotangent doesn't pop up too much. Just know the basic shape. We got our x-intercepts at all multiples of pi over 2. It's like the intercepts and the vertical asymptotes switch. It's like they just switch. You know what I mean? So we're like the vertical asymptotes of tangent are the x-intercepts, and then like what are we talking about here? Then like the vertical asymptotes and stuff. Then like where is it? I'm seeing something and I'm missing it. What is it? Oh, the x-intercepts are right down here. There it is. They match up. The intercepts and the vertical asymptotes change because what makes a vertical asymptote is a 0 in the bottom. That's a vertical asymptote. An x-intercept gets you a 0 up top. So you're just playing that game and flipping it back over. And as long as you know something about sine and cosine, you can graph everything. You can solve everything just by knowing sine and cosine. I don't know if that made any sense, but this is your parent function. Know your parent function. Love your parent function. Know that it has vertical asymptotes, have multiples of pi, and tangent has multiples of pi over 2 has vertical asymptotes. Now let's go over to our cosecant function and our secant function. First, let's just look at cosecant. The way you graph cosecant is you graph sine first. So let's say you're going to give me cosecant of 3x minus pi or some shit. I'm not saying this is the graph. It's not. It's not. I would look at you and be like, nah, dude, I'm actually just going to graph this instead. I'm gonna graph the denominator just to figure out what's going on. And then this would be your graph right through here. You're like, I'm just going to graph it the same way I would graph sine of the whatever bullshit's going on. And then anywhere you'd have a x-intercept, you know, where it equals 0, where y equals 0. So when the denominator, when the denominator equals 0, we get something that's undefined and creates vertical asymptotes. So everywhere we have these, what we just do is we like that, just make some vertical asymptotes. And then you connect your humps. So what's in green is the actual graph. And you keep your humps in between these vertical asymptotes. It's all about knowing where sine equals 0. Notice that this has its domain again is at multiples of pi. The same thing as we had for cotangent, because cotangent has a sine in the denominator and cosecant has a sine in the frickin' denominator. That's why they have the same vertical asymptotes. Now we're going to get to secant, which has a cosine in the denominator. Secant of x is equal to 1 over cosine of x. So if you were to graph cosine of x, you graph that, and then you're like, bro, wherever you got your frickin' x-intercepts, you're like, just make yourself a little vertical asymptote. At all those odd multiples of pi over 2 where cosine of x equals 0, same place where tangent has vertical asymptotes. And then to finish the game off, you're like, dude, just connect your humps. Connect the humps right in between your vertical. They're just little U's and N's. They look almost like they're parabolas that are stuck inside of these. All right, so there's your parent functions. You're going to build off of this. Nice thing about cosecant and secant, our cosecant function and our secant function, is that they still have the same period as sine and cosine. You graph them pretty much the same way as you graph sine and cosine with just an added extra little twist. The difference with tangent and cotangent period is pi. That's the big, big difference. What separates it from the others. It also doesn't have kind of the same shape. It has vertical asymptotes here. But what cosecant and secant never have are x-intercepts. Never equal 0. Cosecant and secant never equal 0. I'll see you in the next one.